Hi, in this video we are going to see about diversity techniques in wireless communication. So diversity techniques, outline of this presentation includes introduction, need of diversity, classification and its techniques. So diversity combining reduces one possible single point failure. Any single receiver failure or local interference to a single receiver will not block reception on the entire system. Equalization and its equipment sites can host many radio transmitters and receivers. A single site is subject to local site-specific interference signals, and it is a powerful communication technique that provides wireless link improvements at relatively low cost. Diversity techniques in wireless communication are crucial for enhancing the reliability and performance of wireless links, particularly in environments with multipath propagation and fading. By transmitting the same information over multiple independent paths or channels, diversity schemes aims to mitigate the effects of fading and improve overall system performance. And the criteria for diversity techniques are: first, the fading in individual branches should have low cross correlation or highly uncorrelated. Second, the mean power available from each branch should be almost equal. It is used to improve reliability by exploiting multiple statistical independent paths for transmitting the same signal, mitigating the effects of fading and interference. These techniques are crucial for achieving reliable wireless communication, especially in challenging environments where signal quality can degrade. The classification of diversity is macro diversity and micro diversity. Macrodiversity provides a method to mitigate the effects of shadowing, while microdiversity provides a method to mitigate the effects of multipath fading. So macrodiversity is also known as site diversity. It utilizes multiple transmitters or receivers that are significantly separated in distance, typically at different physical locations like base stations in cellular network or access points in WLAN. The primary goal of macrodiversity is to overcome the negative effects of large-scale fading, which occurs when radio signals are attenuated or blocked by obstacles like building or other obstructions. By transmitting the same signal from multiple geographically separated locations, macrodiversity increases the probability that at least one of the transmission paths will have a good signal strength, even if others are affected by fading or shadowing. So, microdiversity, it refers to diversity schemes that mitigate small-scale fading by using multiple antenna elements or signal paths separated by distance on the order of wavelength. This is in contrast to microdiversity, which addresses large-scale fading by using antennas or base stations at different sites. Microdiversity technique aims to improve channel reliability by exploiting uncorrelated fading at different locations or at different time intervals. Small-scale fades are characteristic by deep and rapid amplitude fluctuations and occurs as the mobile moves over a distance of just a few wavelengths. Activity. Types of diversity techniques. First one is spatial diversity. This involves using multiple antennas at the receiver, spaced apart by a few wavelengths, to receive the signal from the transmitter. Temporal diversity or Doppler diversity. This technique utilizes multiple transmissions of the same data at different times, taking advantage of the time-varying nature of the channel. Frequency diversity or delay diversity. Multiple copies of the signal are transmitted at different frequencies to exploit the fact that the channel's characteristics may vary across frequencies. Angular diversity or pattern diversity. This approach uses directional antennas to receive only a portion of the scattered signal energy, improving the signal to noise ratio. Polarization diversity. This method takes advantages of the fact that obstacles scatter waves differently based on their polarization by using antennas with different polarizations. Space diversity. It is a technique used multiple antennas at either the transmitter or receiver or both to improve signal quality and reliability by exploiting different propagation paths. It works by transmitting or receiving the signal through multiple antennas that are physically separated, creating independent communication channels. This helps mitigate the effects of fading and interference, leading to a more robust and reliable wireless links. This is the generalized block diagram for space diversity. Space diversity utilizes multiple antennas to create multiple signal paths. Multiple antennas at the transmitter transmit the same signal, allowing for different paths and combining interference. Multiple antennas of the receiver receive the same signal, providing different versions of the signal that can be combined to improve signal quality. The physical separation between the antennas are spaced apart to ensure that they experience different fading conditions and interference patterns. Techniques are employed to combine the signals from the multiple antennas at the receiver to enhance the signal to noise ratio and improve overall performance. The space diversity types are selection, feedback, maximal ratio combining, and equal gain diversities. Selection diversity. So the selection diversity is a receiver-based diversity techniques in wireless communication where the receiver selects the strongest received signal from the multiple antennas, discarding the rest. This approach aims to improve signal quality and reliability by leveraging the most robust signal path available at any given time, which is used to improve the signal to noise ratio. The principle of selection diversity is the selection diversity operates by monitoring the signal to noise ratio or received signal strength at multiple antennas. The receiver then chooses the antenna branch with the highest signal to noise ratio and uses that signal for demodulation and decoding. The benefits of selection diversity is these techniques can significantly improve the reliability of a wireless communication link, especially in environments with strong fading. By selecting the strong signal, selection diversity mitigates the effects of signal variation caused by multipath propagation and other impairments. The implementation, the selection diversity receiver typically requires an antenna array at the receiver and a selection circuit to monitor and choose the best antenna. The implementation can be relatively simple compared to more complex diversity combining schemes. A block diagram is similar to space diversity technique. Next one is scanning diversity. It is also known as feedback or switch and stay combining. Is a diversity technique in wireless communication where multiple signals are scanned in a fixed sequence until one with a signal to noise ratio above a threshold is found. This selected signal is then continuously received until it falls below the threshold, at which point the scanning process restarts. This technique helps improve the reliability of wireless communication by exploiting the random nature of a signal propagation and selecting the strongest available signal at any given time. Maximum ratio combining technique. It is a diversity technique in wireless communication that optimally combines multiple signal paths to enhance signal reception, especially when dealing with fading. It achieves this by weighting each signal path proportionally to its received signal strength and inversely to its noise level, effectively amplifying stronger signal and attenuating weaker ones. This weight combining maximizes the signal to noise ratio at the receiver. Equal gain combining diversity. It is a technique in wireless communication where multiple received signal branches are combined by adding them with equal weights after co-phasing. This method is simpler to implement than maximum ratio combining, as it doesn't require adaptive channel estimation or gain control. EGC provides a significant signal to noise ratio improvement compared to no diversity, but typically about 1 dB less than maximum ratio combining. Polarization diversity. This technique utilizes multiple antenna elements at the receiver, each with a different polarization, to combat fading and improve signal quality. By transmitting and receiving signals with orthogonal polarization, the system can exploit the fading that different polarization experience fading independently, thus enhancing reliability. Polarization diversity involves using antennas with orthogonal polarizations. The receiver combines the received signal from the different polarized antennas, typically using a diversity combining technique. The goal is to improve signal quality by exploiting the fact that fading may affect one polarization more than the other, making the combined signal more robust. The theoretical model of polarization diversity is given in this slide. The polarization diversity. The transmitter transmits signal with a different polarization. The receiver has antenna with corresponding polarization to receive the signals. The receiver then combines the received signal, often using a selection combining technique. The combined signal is more robust to fading than either polarization alone. Frequency diversity. It involves transmitting the same information on multiple different carrier frequencies with a frequency separation greater than the coherence bandwidth of the channel. This technique improves the reliability of communication by making the received signal statistically independent or at least uncorrelated. By spreading the signal over a wider frequency range, the effects of frequency selective fading are mitigated. Frequency diversity. By providing multiple independent copies of the signal, frequency diversity increases the probability of successful reception even in the presence of fading. The same message signal is transmitted at different carrier frequencies. These frequencies are chosen to be far enough apart to be considered independent or uncorrelated by the radio channel. This means that if one frequency experiences a different fade, the other frequencies might still be strong enough to carry the message. Assessment.